So I think so. So for exercise 27, we need to rewrite the logarithm using exponent, which means that I need to think about my base 5 raised to the power, which is my logarithm, and to produce 25. And the power of 5 should be 2 because 5 squared is 25. And that's why I put the 2 here as well. This is my logarithm. This is my power. So logarithms are powers, and that's the whole point of story. So if you try to do a problem like exercise 35 that deals with a natural logarithm or ln, then I can prepare it to write it as a logarithm base e of a square root of e. And if I start wondering what power of e gives me a square root of e, then the power is 1/2, isn't it? Power of 1/2 is same as a square root, and that's why this logarithm is 1/2. There is also a way to double check this using a calculator, and that's, I think, good to be aware of. So you could just put ln and then a square root of e. To go to square root, I go here to where the square roots are located. And then I can just enter letter E here, and you can see the answer right away. This is 0.5, and that's the same thing as 1/2. So we've got the same answer. So in some cases, you can use calculator if you don't have variables present, but if in the exercise there is a variable like x, then you need to work out problems using the, I guess, not a calculator, but by hand. So there are some more of little exercises here at the end of this page, like say problem number 95, and they're all of the same type. They all want you to make that logarithm sign to go away. So if they say that 4 logarithm base 4 of 64 is equal to x, then I can rewrite this as power of x of a base 4 that gives us 64. So this way I can see that 4 to the power of 3, isn't it? 64. If you multiply 4 with 4, it's 16. And then another 4 will give you 64. So your x is equal to 3. Notice the power has to be 3 to give you 64. So the point is that all of these exercises, you want to make the logarithm to disappear. And that's the key idea. How about problem number 93 with a logarithm base e of e raised to the power of x, which is equal to 5. Notice that again, instead of ln, and this is the way to work it out, to rewrite again this e to the power of x. That's a result when I take base e and raise it to the power of 5. So when you get this 5 on one side of the power and x on the other side, then you see that we've got the actual result in here. And that actually makes me think of a very interesting fact of so-called property of logarithm that says if base is a and the base for the power is also a, then all remains is just the power r. Because notice that in the exercise number 93, what I did is I just made everything to disappear and ended up with only a power x, which is 5. And that's all it is. So notice that I record every single lecture that we have here. So if you miss the lecture, all you need to do is check your recordings. And how do you check recordings? Well, you open the email and see what email I sent to you the same day after the lecture. And in that email, you will be able to see the lecture that was recorded. So if you happen to miss a Zoom class, it's not such a big deal because you have a recording of lecture. So what should you do if I send you this recording? Watch it, right? Very simple. I send it to you, you got a lecture, you missed it, so just watch it and you see what we did. And you see the quiz, and you can send me the answer to that quiz by email. But whenever you email me something, always tell me what class you are in. So make sure that you say that you're in 8-week class, Tuesday, Thursday, and that way I'll find you right away and give you this credit back that you missed. So it's not a big deal if you're missing the lectures, and that's, I guess, very good that I record those. In fact, students recommended me to post those recordings somewhere on YouTube because it looks like that some of the recordings disappear because our college keeps them only for 30 days. So what I'm working on right now is posting those college algebra lecture recordings on the YouTube. And by next week, I should be done with that. It's very time consuming because my wife has a channel on YouTube and she offered me to help because I never did this before. So anyways, right now I'm working on this, and next week I'll give you the link to those recordings, and you just click on the link and you'll be able to see whatever you missed, or if you would like to review the lectures, say next semester or next year, they all be there for you. And I think that's very helpful because you could just fast forward through those lectures and definitely recollect what we learned a while ago, because you might need it if you decide to take calculus class, if you decide to change your major, who knows, right, what's going to happen. And that way, I think it'd be very, very helpful that you have access to these lectures, because otherwise it's all going to be gone and you never see this again. And if you forget things, which happens if you're not majoring in mathematics, well, you'll be able to refresh it very, very quickly. So some students recommended me to do this, and I'm glad that I have such an opportunity right now to record lectures and put them on the YouTube, because they don't charge anything for that, right? So I guess it's good to have some free lectures available. So anyways, I'll keep you posted about all that. Next week, I'll let you know what's going on. And now I want to move to the next section that actually talks about the properties of logarithms that I just mentioned here in the upper right corner. They actually have this right here, property number 2. How about that? So if bases are the same, the powers disappear. And notice the property above says if we have the base of exponent and a base of logarithm that are the same, let's say they call them with a letter A, then all stays is just the number that we're taking this logarithm of. So they call it as M. So whatever number is, we have it as the result. There is another very popular property of logarithms that says if I applied logarithm of base A to number 1, then the result is 0, simply because my logarithm is a power, so 0 will be the power that I have to raise my base A to that power of 0 to produce 1, and that's exactly what I get here. Let me try one more property next to it. It's a logarithm base A of letter A. And they say it's 1, simply because if I take base number A here and raise it to the power of 1, which is my logarithm, nothing's going to happen. It's just going to be same letter A. I would like to practice using these properties today. At the end of section, as usual, we see a number of exercises. So why don't I try problem like exercise number 13 to start. That says logarithm base 3 of number 3 raised to the power of 71. What is this going to be equal to? And the answer is 71 because of this very first property that says cancel bases and you just get the power, just like that. And similarly, I can use the property to work out problem number 17 that says if you raise 2 to the power of logarithm base 2 of 7, then all you have is just a 7. So just left with number 7, just like that. So these are neat little properties that give us ability to work out these short little exercises. And I think these sections are much nicer because of that compared to what we went through before, right? Because before we had the tedious exercises. Well, how about exercise 29 that says find the ln of 6. Remember, ln of 6 means logarithm base e of 6. What I can do is just go to the calculator and locate the place where I can find this ln, and that's among the functions. So I need to click on this functional choice. And then you can see ln that appears here a little bit to the right. So if I enter 6, it will give me some answer. And this answer, well, is not very good looking answer. So that's a pure calculator exercise. And I guess the key part is to realize that we have just decimal numbers that correspond to those logarithms. There are 2 more properties for the logarithms that we should consider that refer to things like in exercise 19, where you have a sum of 2 logarithms. One of them is a logarithm base 8 of number 2, and the other is logarithm base 8 of number 4. And it turns out all I have to do is multiply 2 by 4. So this way we end up with a logarithm base 8 of number 8. And I can even write what this is equal to by looking at the property that we have here on the left corner. Actually, it's down below, right here. Logarithm base a of a is equal to 1, simply because this is a power. The power is 1 that I have to raise my base 8, right, to produce the number 8 that sits next to the logarithm sign. So first power is what it is. So when I add logarithms, I multiply. And when I subtract the logarithms, well, then I divide. And this happens simply because my logarithms are actually powers. So if I multiply two exponents with the same basis, all I do is I add those powers together. And if I divide them, then I subtract powers. In other words, I end up here with a logarithm base 8 of 16 divided by 2, which is actually 8. And logarithm base 8 of number 8 is equal to 1. So this is my actual result from previous exercise, right? So it's not very surprising. Well, so let us try some more problems here. Notice they're nice and short little exercises, and well, they just created here for us to practice, to get used to these logarithms a little bit more. So why don't I do something like exercise number 60 that says, take two logarithms and add them together. One of them is logarithm base 2 of 1 over x. And then the other is a logarithm base 2 of 1 over x squared. Well, we just noticed that we're going to get a product, right? We're going to have to multiply 1 over x by 1 over x squared. Well, looks like I can multiply these two fractions, one with the other, and get the answer. Multiply 1 by 1, I get 1 in numerator, and x by x to the second, I'm going to get x cubed. And this is it. This is my result. So it looks like we just follow these properties of logarithms throughout the exercises, and there is one more last property of logarithms that I want to show you here. It's probably the most popular property that says power rule for the logarithms. So if we have a power of some kind of m, exponent m to the power of r, then this power of r could be brought down on the ground and multiplied by logarithm of that number m. So we are able to bring the powers down, and that's the key use of logarithms. So you can bring powers down, or you can put them up. Like if I'm looking at what happens here in exercise 66, then I see that 21 is multiplied by a logarithm of a cube root of x, and this is logarithm of base 3 here. So what I'm going to do is use this 21 now as a power. So I'm going to have to multiply the cube root, actually raise the cube root to the power of 21, which is going to be multiplication of 1/3 by 21, right? Because the power is 1/3 for this x variable. So when I multiply 1/3 by 21, I get 7. So my first piece is actually x to the power of 7. So let me write down this exercise number 66, who is the first term, that is logarithm base 3 of x to the 7th power. I just simplified that a little bit, plus another logarithm base 3, and this is taken of 9x to the 2nd, And then we subtract from this another logarithm of base 3 that we take of 9. So I will put all of these logarithms together and multiply x to the 7th power by 9x squared, and then divide this by 9, just like that. So we produced one single logarithm, and it looks like 9 and 9 I can cancel, right? So we're going to get the result, which is logarithm base 3 of what power of x? Looks like it's 9, right? Because we add 7 with a 2, and we get x to the power of 9. Just like that. So let me check the next section, which actually continues the same story. More exercises of this type appear in it, in the section 5.6. I would say this is all one big section with exercises that deal with logarithms. They just broke it into pieces for us, but, well, doesn't matter. Look at, for example, problem number 8. Doesn't that really look a little bit familiar? Look at this. In exercise number 8 here, I have a logarithm of base 3 taken in the parentheses of 3x minus 1, and this is equal to 2. So my goal is to always rid of that logarithm. So I put base 3, the logarithm is power, so we get 3 squared, which is the same as 3x minus 1. So I produced a little equation, and now we can solve this, right, and get the answer. So point is, whenever you see the logarithm, make it to go away. So you get 10, 3 squared is 9, plus 1 is 10, which is the same as 3x. So we'll divide both sides of this by 3 and get the answer 10 divided by 3, just like that. So how about another exercise, like problem number 11, for example, that actually I want to do exercise number 10 first, and then I'll do number 11. I think 10 nicely precedes 11, because in exercise 10, what you can do is throw away those logarithms. Look at that. On one side of equation, we have logarithm base 3 of 2x plus 3. And this is equal to, on the other side, a logarithm base 3 of number 3. So what I can say is that 2x plus 3 is same as 3, because we are applying the same logarithm to this expression on both sides. In other words, these logarithms are irrelevant, so I can throw them away. And that's the point. You want to have logarithms to disappear in all of these little exercises. So I get that 2x is equal to 0. So, well, x is going to be also equal to 0. And we got the answer. So let us use the power rule for the logarithm that I have here above on this page to work out exercise number 12. Let me try that one. So what I'm going to do is deal with a -2 multiplied by logarithm base 4 of x, and on the other side it's a logarithm base 4 of number 9. And it turns out that -2 is what I have as a power, because My goal, remember, was to make logarithms to disappear. And for that matter, I need to have clean logarithms on both sides of my equation. So there be no logarithm, but x to the power of -2 on one side is equal to number 9 on the other side. So now I need to solve this equation. No logarithms, and that's the point. Well, negative power is something that bothers me. I like positive power. X squared is 9. Or you can clear denominator, so you can write that x squared on the right side and 1/9 on the other side. You say, how did you do that? Well, either proportion rule or you can multiply by x squared on both sides. So x squared cancels. And then divide both sides by 9. So 9 will be in denominator, right? So this way you get this. X squared canceled, 1/9 on one side, and x squared is on the other side. Well, people don't create this mess, but they say that's just a proportion rule. So when you square root both sides, you get 1/3. When you say maybe -1/3 also, no, because x must be positive. Notice that whenever you're dealing with a logarithm, turns out its graph passes through point 1. So if you have a function logarithm base 4 of x, doesn't matter what base is, all of the logarithms pass through point 1. Then the domain of that function, all possibilities for values of variable x, only when x is positive, because graph is on the right side of my y-axis. Nothing is on the left, nothing for negatives. Now that's important to realize that function logarithm has its domain restricted. How about exercise number 35? That's a recommended problem here, right? They have this little pencil next to it. So let me try to find x here. And to be able to find x, I need to bring this x down, put it on the ground, people say. And to be able to do this, I can apply ln on both sides and use this power rule for logarithms. You see how popular this procedure is? When I want to find x, I need to put x like a factor multiplied by something. And then I can divide both sides of this equation by ln of 2, just like that. And we got the answer. X is equal to that fraction. In fact, if you want to see what this is, well, you can just plug this in a calculator, but you're going to get just a decimal. So people leave it like that. I think it's good enough to just keep it as a ln divided by another ln. So power rule brings things on the ground that enables us to solve problems. Let me try number 42, analogous exercise here that has x as a power, and I don't want to have it that x in the power. I want x to be isolated, so I need to bring it down. And for that matter, I'm going to use the logarithms. We already used this in a previous exercise, so I'm applying ln on both sides, right? So these powers will be now multiplied by my ln's. So I'm going to have x plus 1 times ln of 2. Please notice I put this in the parentheses. Make sure that it's entirely multiplied. And analogously with the second piece, I multiply by ln of 5. Again, my goal is to find x. So I need to rid of those parentheses. So I have x multiplied by ln of 2 plus, now multiply 1 by ln of 2. And on the other side, it's ln 5 minus 2x times ln 5. So we need to take this minus 2x and bring it to the left as a plus 2x, right, with ln 5. So we're to find x. So I need to have x terms on one side and everything else on the other side. So I change signs when I bring terms from one side to the other side of equation. Then what we usually do is we factor out x because we need only one term with x, right? And then we're finally gonna divide both sides of this equation by parentheses at ln 2 minus 2 or plus 2 ln 5, right? So I'm gonna put this in denominator underneath my right side as well. And this is it. We're done. We found what our x equals. Well, this is not a very pleasant looking fraction. Well, so what? We got the answer, and that's all we needed. And this is great. So let me try another exercise here, and then I'll have you try something nice. Let me give you something nice. Like number 33, I think is nice exercise. Number 33 has 2, which is raised to the power of x minus 5. And on the other side, it's equal to 2 to the power of 3, isn't it? Number 8 is 2 cubed. So we have same base 2. That's why I'm going to throw it away. So I just have exponents that are equal to each other. And then I will find x. I will add 5 on both sides. That's what we always do when solve equations, right? So we got 8 for x. So we're done. That's the answer. I think it's a nice exercise, right? So maybe 34 will be another nice and enjoyable exercise then. So I hope you will enjoy it for the quiz number 34. Very similar to 33. It looks like you just need to turn 25 into some power of 5, right? So you can find that letter x right away. So this is our